We have a really interesting, diverse group today, but I want to make this as hard-hitting as some of the other panels we've had up to now. I got to tell you, I was blown away by the real estate panel at the beginning, but we've got a really interesting group here today. So without further ado, we're going to do a quick video that Art King put together for us, and let's go to the video, as they say. Marv Albert, right? Let's go to the video.
AECOM is a worldwide multidisciplined consultancy. We have worked on many high-profile global projects. One example of this is that we've worked on many of the buildings that now shape the London skyline. AECOM consolidated its offices into this new HQ for EMEA, here based at Aldgate Tower. As part of the strategy, we decided that we wanted to adopt agile, active-based working. Mobile coverage from all 4 operators was a key consideration, not only for our own workplace but also for guests. Many people think that they've got coverage throughout the country, and why do they need to install an in-building system? The reason behind this is that modern building materials such as the solar performing glass also act as a Faraday cage, restricting the cellular signals coming into the building. OpenCell was one of the suppliers that we'd considered in other systems, and we commenced by appointing them to come in and do a radio frequency survey of the building, which confirmed that the cellular coverage within building was very poor.
Enabled by small cell technology, OpenCell are the first legal multi-operator solution provider in the UK. This solution provides a technology first because working with SpiderCloud, we use their centralized service node technology, and this enables the cost of the service node to be shared across multiple customers. And with the OpenCell design, we share the IP connectivity and the fiber backhaul. What that did then is give 4G high-speed data for one operator and then 3G service for all of the other operators.
The installation was very simple and needed very little space. Based upon standard structured cabling systems back to the comms rooms, all we had to do was add in a few extra points around the building to support the connection of the small cells.
When we first moved into the building, if you were sitting at your desk, you couldn't pick up a mobile phone conversation. Since the solution has been completed, I can pick up a phone call anywhere in the building and not have to worry about losing the other end of the line.
SpiderCloud 4G service delivered over the small cells provides very high bandwidth and low latency speeds. We have full coverage across all floors and all levels. The experience that we've gained here at Aldgate Tower has been essential to us and gives us a knowledge of how the OpenCell and SpiderCloud systems work, a system that we will certainly put forward for other clients and other applications.
So Tony, the actual sponsor of the project, was so happy with the service that he actually consented to do this, to actually make the video. So it was for them it was a very powerful story. If you see the staircase going down between the floors that they showed, they actually had to put a sign at the top of the staircase to tell people to use one hand, because a couple people tumbled down the stairs carrying their coffee and looking at their phone. So from a public safety perspective, putting in the cellular system was actually a problem for them. OpenCell, the vendor mentioned in there, is similar to like Extenet or Geoverse. They're a separate provider that have agreements with all the carriers in the country to install, small cell systems in the buildings for them. Just a quick side note, DAS is kind of unusual in Europe, so they tend to deploy more small cell systems than a DAS. So that's kind of like the thumbnail sketch of the opportunity.
Gotcha. So, staying with you on this topic, so what the title of the panel was intended to kind of bring to bear, where have we really succeeded with these sorts of things and made headway? This seems like one of them, but you probably have a bunch of examples, again, where, the building owner had a problem, and, maybe it was a timing issue, or maybe it was a, coverage issue that was unusual. So where are the success stories that we can all point to that you've had with whether it's the Spider Cloud product or the rest of the Corning line. But give us some examples, if you can, of places where you had a really difficult situation and you came in and succeeded.
Well, we've all got a huge amount of stories, and what we've got things where people have issues like in a particular parking lot. They have work trucks in Maryland for an electric utility where the LTE system wasn't fast enough, and people were having to come in the building to jump on the network to get enough high-speed download to load all their work orders in, and then go back out to the trucks. So we had to put in like an LTE hotspot that was fed from inside the building. So a separate panel antenna had to be put up so that it actually dominated the macro in that particular area to give better downlink speeds for the people in the trucks. So there's a lot of like corner cases out there, Rich, that are kind of out of the ordinary, but there's I think collectively here, all of us have a ton of success stories around satisfying the needs of the needs of our community. A lot of times it's budget, and the people don't have the budget available, or they don't feel they should pay, and they want the carrier to pay. But the carrier doesn't get enough business from the customer to actually justify the investment. So you get into these lockup situations from a business perspective also.
Gotcha. So. Moving on, Jared, you and I have had a lot of discussions about, this topic and where we are in terms of helping folks that have these orphan DAS systems. So, I know the company was recently acquired by Diamond, and so you're now in a new phase of life, if you will. But talk to us about places where you've been able to come in and provide the radio source where basically they were shot and they were sitting there waiting for something to happen. Talk us through that.
Sure. So just to get everyone on the same page, orphan DAS is really a situation where a property owner has either commissioned or has already installed a full indoor system, whatever architecture it might be, and has failed to have been able to get the carrier to connect to it. That could be either because a system integrator was unable to do it, or the property owner built it without having that in place. And in some instances, one in particular we could think of where a third-party owner had signed an exclusive deal with one of the properties we had to get involved with, was promised that they would build the DAS, which I'm sure they're quite capable of doing, and getting multi-carriers connected to that system. And as part of that, the property owner used that information and that contract they had to go sell their tenants on coming into their space and saying, look, we're going to have this high-performing cellular system in our building, and therefore it's going to be high-tech and it's going to enable all the things you want to do over your network. So we're going to command higher rents. And they had tenants say, okay, well, we want to put that into our lease in terms of exactly what kind of coverage we're going to get. And fast forward, right, the property owner was not able to get the DAS installed because the 3PO was unable to get the carriers to commit and come in on the property. And as walls were closing up and things like that started to happen, the property owner said, well, I better just get this DAS installed because it's going to be much more expensive for me to do it once walls are closed up. So they installed the DAS and still couldn't get the system activated by any of the carriers. So we got involved with them once their exclusivity contract had expired with that 3PO, and we were able to bring each of the carriers in under our master signal source agreements that we have with the three main carriers here. So that's one instance where you got to really think and understand, when I'm building the system, is it going to actually be activated once I'm done?
Gotcha. So that's an interesting experience, and that's happening a lot more than anybody, I think, was considering that might happen. So, how often are you called in to kind of save the day on these sorts of things?
Yeah, we get called quite a bit. More often than not, it's a DAS that's already been installed and has one carrier on it, and there's no way to get the second carrier on, where the property owner has either attempted to go directly or through some other third-party advisor or consultant or broker. And I think there's still this this view in the marketplace that the carriers, they'll pay a rent, they'll pay, something, and that hasn't fully evaporated outside the market. What we're seeing is there are very few cases where the carriers are coming in and they're funding these systems, and in even many of the cases, they're not even bringing or willing to bring their signal source gear into it and connect to a system that's fully funded by the property owner. We see it across all verticals. There's no geography that's safe. I mean, we got involved in projects in Manhattan, in California, Texas, North Carolina. So, I mean, I think it happens pretty frequently, in particular where you get the orphan DAS or the underutilized DAS where only one carrier is on it.
Gotcha. So when we were talking before, Walter, I said I was going to go to you next, but I'm going to skip you for a moment if you wouldn't mind, and just go to Shane. So let me tell a quick story. This morning, I came into the room and I was trying to make calls and text, and oddly, in a place like this, in the Broward County Convention Center, there's no coverage in this room on either T-Mobile or Verizon. So we went to went to the building management, the folks that actually run this venue, and we said, "Hey, there's no service in the room. What's the story?" They said, "Oh, we have an AT&T system on the roof here, and so AT&T has good coverage, and they told us they work with everybody, and yeah, you should have fine coverage here because AT&T said it's going to be okay." So I don't mean to drop a dime on them. I'm allowed to because I don't care. And they can, they can do whatever they want to me. But at the end of the day, how often are you seeing this, Shane, where they're not cooperating? One comes in, they want to charge the others a fortune to get on that system. And you're brought in because you're going to try to save the day, and one carrier is doing something and they're fighting with the others. Talk us through that. How often do you see that, and how do you solve it?
I have to be careful here. There is an antenna right there. I'm not sure what's coming out of it, but
it's AT&T, trust me.
The service providers, they're our friends. So I'm not on the side of the fence where I have any desire to badmouth a service provider. They feed us. I do see that, though. There's a lot of systems, the orphan DAS, or just the underutilized DAS. There's a lot of underutilized DASs out there. Even for situations where the enterprise is willing to pay for the source, they've committed to it. They've sent the PO. It could still take them 18 months to get that second service provider onto the network that they built, that they paid for, even though one other service provider is on there. So that's always been a problem, getting that source for all the service providers. But I can't really talk negative about these guys. They're our bread and butter.
But talk us through some situations, this is supposed to be case studies, if you will, where you guys were called in and you had a very difficult situation. It was you were herding cats with all the carriers, or they had already closed the walls and they wanted you to build something. So, I mean, where are we from the standpoint of, the tough ones and handling it? You guys certainly are one of the toughest nails companies out there. How do you handle that?
Yeah, I mean, we work on designs anywhere from a retail store to the largest stadiums in the country and big college campuses, airports, things like that. So we run into a lot of situations. What's relatively new is that a lot of our customers are enterprise customers these days. Used to be 90% service providers and then 3POs, but a lot of enterprises want to build and own and sometimes operate these networks. What happens is we've seen this kind of Faraday cage example, LEED certified building where no RF gets in, and that's why you need some kind of enhancement. I wish that was 100% true. It is to a degree, but the fact is those signals still get in. That's actually a problem, the fact that they still get in. So what separates a commercial cellular solution from any other network or solution in a building is that it's dependent on what's coming in from the outside. When you design a wireless LAN, you design an electrical system or a plumbing system, you can do it off of the floor plans. You know what the environment's going to be like, the building morphology. But when you're designing some kind of commercial cellular solution, the antenna density, the coverage area per antenna is a function of what's actually coming in from the outside. So if you have a dirt lot there's no building there, you don't know what you actually have to overcome. So the device, the user device, the cell phone, wants to talk to one signal, and it's used to talking to the signal that's outside. So if it's competing between the outdoor signal and whatever indoor signal you're bringing in, you get a less than stellar user experience, capacity, throughput, things like this. So in order to design a successful system, you need one that the interior design more than adequately blocks out anything that's getting into the building. So if all these buildings were truly Faraday cages and nothing came in, well then that's a piece of cake in our world. If I can start from 0 RF energy in the building and design a system, that's the best case scenario for us. But one of the reasons that these things are orphaned in some cases that we see is that they're designed to meet a certain KPI, then the building comes up, maybe they're already constructed because people want to get that cable in quick, and they build it to a certain antenna density, certain amplifier density. And then what happens is the service provider then looks at that design before they want to put their source in there. And they say, this doesn't dominate over the incoming outdoor signals. I'm not putting my system on, I'm not putting my RF source on this. It doesn't meet our requirements. Orphan DAS. From simply a design, right?
Gotcha. So, Walter, you guys are primarily in the fiber space. A very important part of the ecosystem. But you were talking when we prepped about the future of C-RAN, D-RAN, X-RAN, and how that all affects the fiber aspect of it. So talk us through that and, kind of what you've done in a success story situation. I mean, you guys are, hooking up fiber like crazy in the areas you cover.
Yes.
But talk us through the rest of the ecosystem, if you will.
So, when we started building our company, we had already had experience in mostly deploying small cell and outdoor DAS in the early 2000s, and we had sold off some companies, and we had a 3-year non-compete, and we sat around and said, what's going to happen? 5G's coming around, and how are we going to make this thing work? And we kept seeing reports that, it was going to have to be antennas on every block, and how do you make that happen from a fiber perspective? We dabbled thinking about, hey, should we get in the in-building space? We saw that some of the other companies mentioned here today are doing in-building. We have a sister company that does construction, and we sort of said, that doesn't look right, because most of the people that were successful were people doing more venues than actually Class A buildings. And we sort of waited on technology to come meet economics, because right now, what we saw in 2014, that technology wasn't really meeting economics. The first project that we were able to work on was providing, using our communications infrastructure, was actually not just fiber, we provided space, power, and connectivity. The big problem was they were trying to deploy DAS in the PAF stations of New York City. And how do you get cooling and power down inside the PAF stations? Well, you really don't. So we were able to build out a base station hotel facility, a network edge co-location facility, and we support all of the PAF stations using our space, power, and connectivity. So it is fiber, it is centralized RAN, C-RAN, if you will. And we're starting to also market that to some of the property owners that are around, and also to using it for tertiary building, for just typical regular telecom, providing edge co-location facilities.
Gotcha. Thank you. So, Brian, you first of all, you had an interesting experience getting here. I think it's worth going over that. It sounded pretty cool, but thank you for being here and getting here on time. So, talk us through what happened to you today and how you fit into the ecosystem now that you're here.
Well, I don't know that I'd call it a cool experience. 3-hour flight delay followed by 2 hours getting a rental car left me pulling into the parking lot 6 minutes before I was supposed to be on stage. So not exactly cool, but it worked out, so I'm here. So we fit into a little bit of a different space, though everything that was just said directly applies in a different scale and with different equipment, but all of the same challenges apply for us. But with that said, I have one big bone to pick with my fellow panelists, and that's, as an industry, there's not enough differentiation between when someone says wireless, do they mean device wireless for things like laptops, tablets, phones, TVs, smart TVs for thermostats, in other words, Wi-Fi, or do they mean cellular wireless? Because when we talk in the wireless space, we're talking on the Wi-Fi side of things, providing internet connectivity into dense population centers such as high-rise apartment buildings and typically Class B office buildings. So we'll go into a property that has as many as 1,000 tenants in a single structure. Every one of those tenants wants to have a wireless network inside their apartment that they have control over, that they want to have privacy on. They want to have their devices connected. They don't want to have a hotel-type splash page and hotspot. And so how do you manage that and not have them going to the cable company? So our issues are both the signal density, the outside interference. We love buildings that don't have other RF noise. Same story, same scenario, but we're coming at it from the 2.4 and the 5.8 gigahertz spectrum as opposed to cellular. So, and also 2014, I completely agree, the technology wasn't out there to do these things, which is exactly why we exist. In 2014, we took our experience as having been a regional ISP, where we covered 2,500 square miles of the state of Indiana with broadband, switching most of our subscribers for the first time off of dial-up onto a true broadband experience, which was enlightening, to say the least, when you're teaching someone how to use broadband after being on AOL for their whole life. So we took that and we adopted that to multi-tenant properties, whether it be apartment or commercial space. And we built out a whole technology suite in order to manage those environments without having to have all the skill sets of network engineers and ISP staff in-house, so that you could go into those buildings and deploy the same type of scenarios without having 10 guys on staff that are $100,000 salaries. And the main issues that we ran into, we sell through the channel, so we have resellers all over the country, and the main issues that they're running into are getting through the building, the wiring, buildings that are built with only coax, and they don't have provisions for pulling anything else during construction. They let the cable company come in, the walls are all closed up, they have no cable pathways to pull new wires, and the cables are owned by the cable company, so they're very, very restricted on what they can do. So typically they end up going through, in one of the best stories, AT&T brought in a fiber circuit into the basement of a building. What they didn't realize when AT&T brought the fiber circuit into the building was that they terminated it in the garbage room. And the only access out of that room for cabling was through the garbage chute. So up to the 20th floor of this building, there's actually 3 buildings on the property. Up through the garbage chutes of all 3 buildings is Corning outdoor fiber running through the garbage chute, so that it's strong enough to not get destroyed by the tenants dumping the garbage down the chute.
Are you saying that Corning fiber is garbage?
Well, wasn't going there.
I hope that's not what you're saying. But it's so it's tough enough to withstand that environment.
Yes, it's tough enough to
All right,
withstand the
there you go.
environment. And so they actually then went out of the garbage chute and came around the corner and then went up to the ceiling through the plenum and went down to the closets on each of the, I think they did every other floor of the building to run their horizontal runs in copper into the apartments.
Okay.
So there's a lot of interesting things when you're retrofitting buildings that were built 30 years ago.
So Art, back to you. So we've established that Corning fiber is great and very tough.
Yeah, what he said.
Yeah. So, but I want to go back to you. So, based on what we've all talked about in terms of the difficulty here and orphan DAS and all that, so obviously the Spider Cloud product is something that you've got control of, but are you finding the same difficulty when you're putting Spider Cloud in getting the carrier to allot frequency for that, in the Spider Cloud product?
Well, there's actually no frequency allocation. It still uses the macro outdoor frequency. What's been put in place with all 3 operators that we're approved for in the U.S. is a what's called customer-owned ERAN, where whether the driving a DAS and being used on the head end instead of a regular base station, or whether it's being used in a traditional small cell deployment, kind of like Wi-Fi is with radios distributed through the ceiling. There's an approval process that's been developed by the operators so that the local RAN people check off on the design and check off on the frequencies we're going to be using, et cetera. So it's really, the operators don't lose control, but the customer's allowed to write a check and get things done. There's still, a time delay of, a certain amount of time, but we've got an SLA process that's actually been set up with the operators, and it's centralized so that the system integrators don't have to interact with the operators, because a lot of times these things are relationship driven, and they're not so much driven by just calling a random phone number. Shane can probably call any of the people he knows in a RAN market and get consensus on doing something very quickly, because they know that his operation and his skills are up to par, and that if he says he's going to do something, it's going to happen that way. But you can't just cold call some of these operators without that, because you'll get questioned quite a bit more.
So, Art, just straighten me out on this part of it. So Spider Cloud is not sort of like a repeater that's bringing macro signal in from out of the building, or is it? What is the Spider Cloud radio doing?
It's like a base station in the palm of your hands, really. It radiates RF, but on the backside of it, it's PoE IP packets. So it's really, all the RF is at the edge in the box.
Got it. But it's not a base station in and of itself, or is it repeating macro signal like a repeater?
No, it has no interaction with the macro. It's actually connected over terrestrial fiber to the core network.
I got you. Okay, gotcha. So, but moving on to Jared. Jared, you could see why customers who are gun shy about this might want to use something in the line of a repeater, to pull signal from the outside, and then repeat it in the building rather than go through the trauma of waiting or not knowing. So how do you view that, and is that a legitimate alternative to us putting a base station in these properties?
I think what you have to do when you assess any property, and I think it's something that is not often done enough up front, is really understand, what am I using this system for? What do I intend for it to do? How long do I intend for it to last? What kind of life cycle management do I want over it? How much do I have in my budget to spend? Because do I have $75,000 to fix an issue, or do I have $750,000 to fix the issue? Am I trying to cover the place to first impressions and just the lobby of a hotel, or do I want to paint the corner of every room in the hotel? And I think those things drive you towards what solutions can possibly apply for that situation. But I think what happens often is, in the sales cycle, you get an opportunity and you just run out there with, here's a bid, we're going to design something. You end up with these Cadillac solutions, or solutions that just don't make sense. And part of the other factor that really weighs in here, that I think is not often considered enough, is up front, as you're thinking about this, and whether you're going to go with you're going to attempt to try to get carrier dollars out of the system and try to get funding for your DAS or whatever your architecture is going to be, or you're resolved to say, look, I'm not waiting for the carrier. I want to take control of my own destiny. I want to just build it and fund it, because the principles of what your coverage requirements are could be different depending if you're funding it.
There are a whole host of problems with doing that. I understand it's a quick and easy, low-cost solution. However, first off, garbage in, garbage out. So if you don't have a clean signal where you're trying to grab it, if you're in a high-dense area or whatever the case may be, that's only as good as you're going to get. Right? Whereas a small cell type of deployment, that's a crystal clean signal starting from scratch. Also, you've got other things like oscillations that can happen, and these things could actually start to, like a feedback loop when I put this speaker next to or microphone next to the speaker. What that can do, and I've seen this, a hospital tried to put a repeater-fed fiber distribution in there. It shut down an entire city. The service provider was knocking on their door saying, shut it down. It was shutting down nearby cell towers everywhere because things oscillating and feeding back into the system. Also, if things get in the way, if someone moves that antenna on the roof or does anything, the reliability of your network is skeptical. So there are quick fixes, but they come at a price, just like anything else.
Got it.
I have one quick thing to add to that. I have a saying that I like to repeat, which is that the quality of your wireless is directly proportional to the distance you are from the wire.
Yeah, that makes perfect sense. But so Shane, just to stay on topic with you, so you're doing these things for customers that have, a real desire to get coverage in their space, and now we talked about it could be 18 months. So I guess I'll use the scales of justice here. Kind of a raggedy signal using a repeater, nothing. Raggedy signal using a repeater, nothing. How do you balance those two when you're looking at designing something to help a client?
Well, there are a lot of kind of temp to perm solutions that happen out there when they're waiting for their final solution. Repeater is one of those. And we're all in this industry very familiar with how repeaters operate and how they're designed. But there's quick to deploy small cells. I mean, the example of the Spider Cloud. You can get a Spider Cloud up in operation in a relatively short amount of time. So if I had my choice between a brand new clean signal and something that I'm unsure about over time, I'm going to pick the clean signal.
Gotcha. Yeah. So Walter, you are the wire guy, and everybody wants to get as close with you as possible to get that great signal.
Right.
So you mentioned CRAN before.
Yeah.
How does that ecosystem work for you in terms of getting close and having CRAN, DRAN, XRAN, or whatever it might be?
So what we like to do is become pretty agnostic from a design standpoint. These are a lot of guys that are a lot smarter than us. We do the physical space, power, and connectivity, but what we believe is going to happen, and especially in areas like New York City, where everything's real dense, where repeaters don't work, even people having deploying DAS because of somebody mentioned union. By the way, full disclosure, our sister company is a union shop. So I can say it. We know that the economics don't work. And at some point, there has to become, this whole physical layer infrastructure has to become almost a utility. And on one side of the utility, we have a lot of, we convince and work with the carriers to be in our facilities, and I'm sure you'll see Crown doing it. I'm sure at some point you'll see XNet doing it. You hear them talk about shared infrastructure all the time. That's going to be the way to go in the metro area. It only makes sense if we're really going to ever get to 5G with everyone bringing their own devices. There's not enough help from a lot of different areas. One is the municipalities. Think about in the municipalities, they only release what they call a reservation period, so we can even go get on a pole maybe once a year. So each of us get a small amount, 300. If you think about how many 5G antennas need to go outdoors to support 5G adequately, it's not going to make sense. So if you think it's going to go into your building and they're going to, you'll get some bleed over from macro sites. You guys know better than that. I think at the end of the day, there has to be some economics looked at from the building owner side in order to have some type of utility that they could plug into. We hope it's going to be our physical layer communications infrastructure, whether they design DRAN, XRAN, or shared infrastructure like we have already with CRAN. That's really up to them. We just want to be able to facilitate it.
Gotcha. So, Brian, from your standpoint, you're in a little bit of a different situation, but do the same rules apply for your business in terms of interference, in terms of getting things done in buildings that they apply to in the DAS world, or is it completely different sort of circumstances for you?
There's a lot of parallels. There's a lot of differences as well. When we're deploying systems in buildings, we're talking about getting an Ethernet cable terminated into every apartment or every office in the building, and so we're putting in effectively a DAS system, but it's by broadcasting signal off of the device inside each of those spaces, which helps eliminate some of those problems with getting coverage to every corner of the building because we're broadcasting from inside every space. and we're using low power radios to so we can have the density. If you've got 1,000 devices broadcasting inside of a structure, they have to be low power. You can't have the big Netgear $500 Best Buy specials or whatever they advertise broadcasting. You're going to take out half the floor or half the building with those things. So we really encourage systems to be on the 5 gigahertz because it has lower penetration through the walls for that same reason. When it comes to the cabling itself, we do have the luxury that most of those cabling issues are not outside. It's the building owner. They're controlling who has access to the conduit in their buildings. So most of the time, it's a pretty straightforward process of just getting the budget approved. Does the property owner allow the provider to go in and pull that cable through? And when I say provider, I don't mean the cable company. I mean our dealer, which would be someone like you going in and pulling that cable through the building. The wiring to the building, which is going to come from a fiber carrier of some sort, yes, all those same issues still apply. And I have a conference call tomorrow with one of our partners in California. They needed to upgrade their circuit, and the fiber provider said, well, we can't upgrade that. We're installing a whole new fiber into the building. It's going into a different location. We have to install different equipment. It's coming from a different direction down the street on different conduit. And so there's a whole coordination process.
Not going through the garbage chute?
No, thankfully
Sounds
not.
like poor planning. On the
Sound-
fiber fire.
Sounds like AT&T.
So one last run through, Art, starting with you. I designed this sort of as panel on successful case studies. You certainly by the way, I have to compliment you. You wrote the 2 of the best stories for our magazine. One called "Don't Wait" and the other called "And Now for Something Completely Different." Now, I don't know how many people in the audience will get the reference, but it was a good one. But Art, success stories. What have you guys used Spider Cloud to solve a problem? Give me one good case study, and we'll move on.
Quick comment about 5G. 5G as deployed in the United States is called non-standalone. It requires an LTE layer underneath it. So every place that you're installing LTE, 5G is going to be layered on top of that to create the 5G NSA service. So any of these buildings that you see where they don't have LTE yet, when they go for 5G, they're going to have to add LTE into it also. So kind of that's a thing that most people aren't aware of, is that you have LTE underneath 5G NSA as is deployed.
Very helpful. Thank you.
Yeah. On the case study side, we've got thousands of buildings installed, and I think the core message is that as we looked across our database of installed sites, there is no one vertical that dominates. Cellular need is driven all across the landscape. It's not vertical market specific as far as anyone dominating it.
So it's hospitals, hotels, it's the apartment buildings, it's offices, etc.
It's every vertical market. There's a huge amount of demand for it, and it's like in the world we live in, there's like 2 types of telecom managers. There's ones that think Wi-Fi will do everything, and then there's ones that have actually tried it that think that a rational mix of both technologies will meet their wireless needs, and the people are kind of demanding it, as the employees are seeing it, especially the younger people are seeing it as it's like digital oxygen. I mean, they really think that it just should be there, and we don't understand why there's no cellular here. So more and more cellular will be like a utility, and the thing that has to happen is that when people budget to do it, they can't have a cost overrun on the lobby, as we were talking about earlier. You can't have a cost overrun in the lobby and take away your construction budget for your wireless infrastructure. You need to protect it. When you when you do a new building nowadays, doing it without cellular is like not installing toilets, because, well, we ran out of budget, so we didn't put toilets in the building. I mean,
No, to your point, I met somebody at a show not too long ago who had a smart locking system, and I asked what platform it worked on. They said the building's Wi-Fi. The building's Wi-Fi. Whose Wi-Fi is that? Who owns that? Well, the building owns that. But they were under the impression that Wi-Fi was ubiquitous. It just happens, and so not the way it works, unfortunately.
We haven't reached the tipping point yet where CRE has Wi-Fi in scope. Wi-Fi is still generally an enterprise technology. I think at some point, when you move into buildings a decade from now, Wi-Fi and cellular will just be there as part of the experience, and when you lease the building, it'll all be there.
Gotcha. Jared, you want to go and talk about the success story you've got on this and give us one example?
Yeah, sure. So I think the timeline that you talked about before, and certainly when you're waiting for the carrier to come in, if you miss a plan of record year or the build plan, you can certainly get delayed a year or longer, or even longer than that, to an indefinite status and not really have certainty. So we've had a number of experiences, one in particular building in Times Square, Manhattan, where the property owner needed the cellular network up and running by the time they opened the hotel, because their view was, if we open this hotel and on TripAdvisor people give us a crappy rating because they have to go outside in the middle of Times Square to make a phone call, what that's going to cost us in their average daily rate and occupancy per night compared to the cost of putting the system in, we just can't risk that. And I've got to get it done before we open the doors, right? And as you can imagine, with any project, there's all kinds of problems. The fiber that was going to come into the building, they had it on one side, then they changed it to the other side, and when they changed it to the other side, there was 4 feet of concrete in the foundation to put the penetration underneath and get in. So we had to kind of figure that out and garbage chute kind of scenario. Get into some kind of unique agreements, fiber sharing agreements, which are not very common between the carriers and things like that. But at the end of the day, through the program that we have, we were able to get the system up and running in a lot shorter than 18 months. I can't tell you every system is going to get done in 3 to 4 months, is I think what the industry really is striving for and hoping to get to. But I think a reasonable time period can be around a 6 to 5 to 8 month time period to get a system connected back to the carrier network. At times we're able to accelerate that depending on what the building is, and everyone's got a card or two to pull and call in some favors to get it done a little bit faster, but that's kind of how we've approached it.
Good. Shane, one good one from you?
Well, since we work with all this, we work with all the DAS and small cell manufacturers, but since Art's right here, I'll give a little love to the system that we worked with their product. There are some models out there right now where people think they base these financial models on the evolution of these distribution systems as if the technology will get less expensive over time, like computers. And these models are built that way, but we've seen just the opposite. These systems that we're designing and deploying are becoming increasingly more complex and more dense. For example, a stadium that once had a handful of antennas around it now has well over 1,000 antennas under the seats, right, for these really high sector count, 300 sector count type of deployments. We've recently we're the company that does all the stuff behind the scenes, so we can never talk about anything we do. We just get to watch everyone bask in the glory after these big Super Bowl events and these big, arena events. But recently, a brand new arena in the West Coast, we deployed with the Corning One platform. It's a fiber to the edge DAS kind of deployment. And that's never been done at that size and density before with the number of, basically almost every 10 seats, there's an antenna under these things. And that's never really been pulled. That was probably the first one done like that. That's launched completely from square one. So that was a big deal. And I think the closer you get to the amplifier, you're starting to see these systems, small cell distributions, amp at the edge, all the manufacturers that create a traditional DAS with the amp in the closet and coax out, they're also creating an amp at the edge solution. The closer the user can be to the amplifier, the better experience they'll get with throughput and connectivity, and that's what we're seeing.
Gotcha. So, Walter, that's you. You get everybody close as possible to the signal source.
You keep giving me business opportunities.
Well, that's the
I like
point,
that.
isn't it?
I like that. I like that.
Good. So, but success story, you guys have done an enormous amount of different things in New York, and you have a lot of those. Give us one good one.
So the one with the pass stations I thought was really good because we delivered the whole thing in under 3 months. It was amazing, a lot of power and ran the fiber and everything in under 3 months. I think the biggest issues that we run into in our neck of the woods and where we are is dealing with all the municipalities issues, and as well as having to deal with one of the carriers, because typically what we try to do is when we're pulling fiber into buildings to support you, we try to use the best economics, and the best economics happens to be a co-occupiable MPOE with conduit already out to the street. New York has done something very, very well, which is they have mostly a conduit system that's actually in the street. It's called the ECS, Empire City Subway. It's very accessible, and we run a lot of cables through that. So in continuing to build out this network, we have some interesting things that we've done. From a design perspective, is we had to deal with this problem of if you needed an antenna on every street corner, what would you do? One of the projects that we work on, it's actually public Wi-Fi, and it's the payphone replacement project that uses our infrastructure throughout all of New York City. The biggest issue was when they were going to go replace, the goal was to replace at some point 7,500 payphones. If you think about that, and you're going through the streets of Manhattan, how do you get into the pole and provide, how do you break into the street and not only provide fiber, but then now you gotta have somewhere to aggregate it because I'm supporting public Wi-Fi. And we use shared co-location facilities to do this. And we also have a cable that we've designed where we can access it at any manhole that we traverse.